A very good morning to all of you. Let us start analysis of 2015 Bullcat 7. Let us start. The very first question. Any problem? This is raised to power m. Yeah, any problem in this question? Question number 1. Paper was very difficult. So, yes, okay, Bhavya. Let us see. It says x and y are single-digit natural numbers and with x is more than equal to y such that for any value of m, x plus y whole raised to power m has the same unit digit as x plus y. It means if we take x plus y whole raised to power m or x plus y, the unit place should be same always. Whatever be the value of m, it means if we take any power of x plus y, the unit digit should be same always. So, as we know, if number ends in 0, 5, 6 or 1, whatever be the power, the unit place will remain same. I mean to say if x plus y is ending in 5 or 0 or 6 or 1, you take any power of x plus y, unit digit will remain same always. Are you getting me, Bhavya? So, we'll consider all the possible cases. Now, I have considered that x plus y should end in 0, 5, 6, 1. Now, x and y, they both are natural numbers. So, the value we can take of x plus y, it can be 10. It cannot be 0 because x and y, they both are natural numbers. So, x plus y can be equal to 10. It can be 5. It can be 15 as well. It cannot be 25 because x and y, the utmost value should be 9 always. For x plus y, the utmost value is 18. It can be 6, it can be 16, it can be 1, it can be 11. So, whatever be the power of x plus y, will get the same unit digit always. So, one condition is okay. Now, coming to other condition. xy and xy raised to power m, whatever be the power of m, unit place should always be same. So, let us consider cases. So, if I consider x plus y as 10, how many possibilities are here? 1, 9. X can be 1, y can be 9 and a vice versa case as well. 2, 8, 3, 7, 4, 6, 5, 5. Now if I consider this case where x is taking value 1 and y is taking value 9. What will be xy? It will be 9. But if we take xy square, it will end in 1. So this case is rejected. But if we take 2 and 8, xy will be 16. So whatever be the power of xy, x into y, unit digit will remain same always, that is 6. So this case is considered, this is a valid case. Are you getting me? Now what is xy? This is 21. Now number is ending in 1. Of course, you take any power of xy, the number will always end in 1. That's why this is also a permissible case. Now coming to 4, 6. If we take xy, it will be 24, rejected, because you will take powers, you will get either 4 or 6 as the unit place. But the unit place should be same always. That's why this case is rejected. xy is 25, this case is in whatever be the power, the number will end. I mean xy will end in 5 only. So these three cases are valid in case when x plus y is 10. Are you getting me or not? Now coming to 5. If x plus y is 5, how many possibilities are here? We can take 1, 4. We can take 2, 3. That's it. But if we take multiplication 1, 4, it will be 4, rejected. If we take 2, 3, if we take multiplication, this is in case. This is a permissible case. Now if we take 15, 15 can be 9, 6 because x and y, they both are natural numbers. That is the only possibility. 9, 6, it will end in 4. 9, 6 are 54. So that is not a valid case, because if you take unit place as 4 and you raise powers, the unit place either will be 4 or 6. It keeps on changing, but we need same unit place. That's why this case also is rejected. Are you getting me, guys? So in the same manner, we'll count all the cases and we can proceed further. You got the idea, all of you? Yes, guys, please confirm. Can you hear me? No, Bhavya, no. That's why I have included that question in difficult ones. You have to consider each and every case and you have to check it for x and y. You got the concept, Bhavya? Okay, let us move further. Question number 2. I'll say this is an easy question if you know Pythagorean triplets. Any problem in question number 2? If you have problem, please write explain. Okay, let us see, Rashmita. A fly is on the outer tip of a fan blade. Say this is the fan. This is the outer tip. A fly is sitting here and is exactly 24 centimeter away from the center of the fan. Say this length is 24. The fly then walks toward the center of the fan after 4 seconds, during which the blade rotates through an angle of 90 degrees. This is 90 degree. It appears that the fly has been displaced from its original position by 25 centimeters. Now this is the initial position. This is the final position of the blade. Now fly is moving towards the center. Suppose this is the new position. The new position and the initial position, they are 25 centimeter apart. It means this length is given. You got, Rashmita? You got that? With 24 and 25, do we have any Pythagorean triplet? Yes. This is, yes, any one of you? This is 7, 24, 25. So this length should be 7. What was the blade length? It was 24 centimeter only. So fly must have covered 24 minus 7, that is the remaining distance. I mean 17 centimeter in 4 seconds. Yes, of course, Rashmita. So the fly has covered 17 centimeter in 4 seconds. So you can write the speed of the fly, which comes out to be 17 by 4. Clear? Very easy question it was. No need to go into equations. So let us move further. Question number 6. Time consuming, difficult one. Any problem in this question, guys? Yes, Preeti, Rashmita, Tanya, yes, Adhiraj. See, find the number of quadratic polynomials dx squared plus ex plus f such that following conditions are satisfied. First, d, e, f are distinct. D, E, F belongs to this set 1, 2, 3, so on up to 2008. And C is x plus 1 divides dx squared plus ex plus f. Now I am taking the third direction. X plus 1 is dividing it completely. If x plus 1 is dividing it completely, it means x is equal to minus 1 is the root of this polynomial, is the 0 of this polynomial. So by putting values, we can say this should be equal to 0. Now it says d minus e plus f is equal to 0, which says d plus f is equal to e. You got that first of all? Yes, guys. C direction I have explained. Clear? Okay. Now D, E, F, they should be distinct, and D, E, F belongs to 1, 2, 3, so on up to 2008. Now since D, E, F, they all are distinct, the minimum value of E can be 3. Because one of D and F can take value 1 and other one will be 2. The minimum value of E can be 3. So I'll start with this. D plus F, that should be equal to E. If I take E as 3, 4, 5, the maximum value can be 2008. So how many solutions are possible for this equation? D plus F is equal to 3. Can you say there are only two possibilities? Either it can be 1 plus 2 or it can be 2 plus 1. Similarly for 4. If I consider all the possibilities, I'm not considering the first thing that D, E, F, they are distinct. I'll subtract all those cases where D, E, F, at least two of them are same. So I'm considering all the possible cases here. D, F, the total should be 4. It can be 1, 3. I'm not going into any equation any formula because that is easy, I think. It will be 3. Now coming to this, the first solution possible is 1, 2007 and the last will be 2007, 1. So in total, there are how many possibilities? 2 plus 3 plus 4 plus so on up to 2007. Are you getting me, guys? So these many, yes, Shubhadeep, I'm coming to this. I have considered all the possible cases because, yes, Vartika, of course, we will subtract all those cases where D and F, they both are same. Now, if I consider, say, 3. Since 3 is an odd number, D and F, they cannot be same always. Is it okay? But in case of even numbers, if I consider 4, in case of even numbers, there will be a case where D and F are same. So in every case of even number, we'll get a case where D and F are same. That's why, first of all, we'll consider how many even numbers are here till 2008. How many even numbers are here? They are 1004. But since we are starting the series from 3, that's why 2 we have not considered. So we are left with only 1003 even numbers, and corresponding to these 1003 even numbers, there is a case where D and F are same. Is it okay with you? Vartika, it should be 1003. Yes, it should be 1003. So I'll consider 2 plus 3 plus 4 so on up to 2007. You can apply a summation and formula minus 1003. This will be the final answer in this case. Is it okay, guys? Rituparna, your question, you said, ma'am, only the positive solutions we considered. See, there is given a set. They have given a set that D, E, F belongs to this set. So we can consider only these many values. Is it okay, Rituparna? We cannot go beyond this set. Please confirm, Ritu. Let us move further. Yes, Ritu, it is given that they have distinct values. That's why we are subtracting 1003. We have subtracted all those cases where D and F are same. Because if you go case by case, it will be cumbersome. You will not get any series here. Okay, I'm moving further. Question number 7. Yes, question number 7. Any problem? Very good question on circular motion. Yes, Rituparna. Two friends A and B simultaneously start running around the circular track. They run in the same direction. A travels at 6 meters per second, B runs at B meter per second. If they cross each other at exactly 2 points on the circular track and B is the natural number less than 30, how many values can we take? To solve this sum, I need a shortcut. What is that shortcut? Whenever you have a circular track, say this is the initial point. Suppose there are two persons A and B. I'm taking new data. Suppose A speed is 30 meters per second. B speed is 45 meters per second. And they both are moving in the same direction. Now we want to solve that at how many distinct points of the track A and B will meet. Suppose this is my question. What is the shortcut to solve this question? We'll take the speeds. Yes, Barry Bonds, exactly. We'll take the lowest terms, ratio of speeds in lowest term, which comes out to be 3:2. So we'll take the subtraction, which comes out to be 3 minus 2, 1. So they will meet only at one point, that 2 is the initial point. Had the speed been opposite, direction being opposite. If directions are opposite, then they will meet at 3 plus 2, 5 points. Do you know this, Rashmita? Clear? Okay. So, Rituparna. Okay. Let us start this question now. It says that one person's speed is 6 meters per second and another one is B, and they're both moving in same direction, and they are meeting at 2 points only, and B is less than 30. How many values can B take? So let us solve. Now what was the shortcut? We will cancel the lowest, we will convert this ratio into the lowest term. So we will cancel the HCF. So basically what are we doing here? We'll take modulus of 6 minus B, because we don't know whether B is less than 6 or more than 6. So we will consider both these cases, divided by. Why am I dividing? Because we are cancelling the highest common factor. That is the meaning of converting this into lowest ratio. Are you getting me, Rituparna? That is equal to 2. You got that? That is a shortcut we have discussed in many bull mocks, many previous bull mocks. The same thing I have written in the equation format. So let us see. HCF of 6 and B, that can be what? See this F means what? Factor. So HCF of 6 and B, that should be a factor of 6 as well. So HCF of 6B can be 1, it can be 2, it can be 3, it can be 6. So if I consider HCF to be 1, so 6 minus B, its modulus should be equal to 2. 6 minus B, it should be equal to plus minus 2. We'll solve both these values. So which comes out to be 8 and 4. But if we consider 6 and 8, 6 and 4. If we consider 6 and 8, we convert this in lowest ratio. See, 2 is cancelled. There is only 1 point. That's why this case is rejected. Now take the second case. Again, this case is rejected. That's why this is not our answer. Are you getting me? Rituparna, that was your problem. HCF should be 1 always in these cases. Now coming to second case, where I am considering that HCF is 2. If HCF is 2, modulus of 6 minus B, it should be equal to 2 into 2, that is 4. So 6 minus B, it should be equal to plus minus 4. So B minus 6, or we can say B will be 6 plus minus 4. So it can be 2, it can be 10. But if we consider 2 with 6, if we consider both these speeds, this is a possible case. If we consider 6 and 10, this is again a possible case. Are you getting me? Yes, 2, 10. These two are possible case by taking HCF as 2. Similarly, you will calculate for 3 and 6. Only one value you will get, only one more value, that is 18. That's why we have got only 3 values of B. You got that? That is a plain usage of the formula only, the shortcut only. Clear? Should I move further, guys? Okay. Let us move. Question number 8. Any problem in this? Okay, let us move. Question number 18. I don't know why many students have left this question, but it was very easy. Any problem in this question? Question number 18. If you want me to explain this question, please write explain. Yes, just Karan and Preeti. Find the smallest positive integer k such that k into, this is k into 3 cube plus 4 cube plus 5 cube plus 6 cube is equal to a raised to power n for some n always. Okay, now as we know, what is this? This is 432. It should be k into 432 should be nth power of any natural number for some positive integer. So 432, if we write the prime factorization, it will be 2 raised to power 4 into 3 cube is equal to a raised to power n. As we know, n cannot be 3 as we have 4 here. So if I take k as 3, it will become 2 raised to power 4 into 3 raised to power 4. So it will be nothing but 6 raised to power 4, because we need smallest positive integer. That's why k should be what? It should be 3. You could go by options in this case. Is it okay, Abhiraj, Karan, Preeti? Okay, let us move. Question number 25 and 26. Yeah, any problem in this? Yes, Preeti. Okay, Bhavya. Rituparna. Let us see. First of all, PQ is equal to AB. So if I consider this as X, this AB will be X. And AB is nothing but the radii of both these circles. Because A and B, they both are given as centers. Now the first condition, the ratio of the area of the shaded region and the area of each circle is K in the figure 2. In figure 1, the ratio of the area of the shaded region. So this region, let us call it 1. This 1 divided by area of the square PQRS is P. What is the area of the PQRS square? It will be X square. This is given as K. Is it okay? Area of each, the ratio of the area of the shaded region and the area of each circle is K. Just a second, I have made a mistake, I think. It is given that the shaded region in figure 1 and its ratio with the area of the circle, which comes out to be pi x square. This is given as K. It means we can conclude that this shaded region is nothing but K pi x square. You got that? This shaded region is equal to K pi x square. Yes, because that was given as K. So let us move. Find P in terms of K. We want to find P. Now what was P? P is in figure 2, the ratio of the area of the shaded region and area of the square PQRS is P. So let us see what is the thing. Now we want to find in figure 2 the ratio of the area of the shaded region. We want to find this area. How can we find this area? First of all, we will take square area, which is x square. Out of this, we will subtract this quadrant twice. Why so? Because there are two quadrants, two circular quadrants. Are you getting me? With the radius of x. So twice of, what is quadrant area? Circle by 4. So it will be pi x square by 4. But this area is counted twice. This area is counted twice. Are you getting me, guys? So plus, I'm taking this area, suppose as 2. Clear? Okay. Now what was the question? Find P in terms of K. Now divided by, I'm taking second line. In figure 2, the ratio of the area of the shaded region and the area of the square. What was the area of the square? It was x square. This is given as P. So we want to find P in terms of K. Now we will calculate this area, second area. Now coming to the last line, the ratio of the combined area of the closed region PST and QRT. PST and QRT. It means this area and this area. This is equal to, and the area of each of the circle in figure 1 is M. By taking this, you can substitute the value of second. Are you getting me, guys? Now you can, yes, you can put the values. You will get the answer of P in terms of K. You got that? Actually, I need this figure. Let me use another page. See what was given. There were two circles and some shaded region. These were the centers and there were two quadrants this way. That was a shaded region. Now coming to question. What is the thing given? The first line given is PQ is equal to AB. Now this was AB and this was PQ. I am considering this is X and this is X. So area of each circle will be pi x square and area of square will be x square. I am using formulas only. The ratio of the area of shaded region in figure 1 and the area of each circle is K. So I'm making use of first direction, that is the ratio of the area of the shaded region divided by, and the area of each circle, which comes out to be pi x square. This pi x square is equal to k. So can you say this shaded region in figure 1 will be kx pi x square? Can you say this? Now once again, can you say this shape and this shape, they both are similar actually, with the same radius? Can you say this, Preeti? Ashish, that is mentioned in the question only, that A and B, they both are centers. So its area, this red shape's area will be k pi x square. Can you say this? Divided by 2. Because that complete area, shaded region's area, we have calculated k pi x square. So in another figure, we have half of that shape. That's why this area will be k pi x square by 2. Clear? Now coming to second line, in which P is mentioned. In figure 2, the ratio of area of the shaded region and the area of the square PQRS is P. Now, in figure 2, I mean square figure, we are writing the area for the shaded region. First of all, I'll write the square area minus. We need this thing only, the shaded region only. So we have to subtract the remaining area. So if we subtract the remaining area, it will be a complete quadrant 2 times. We'll subtract these 2 quadrants, and quadrant area is what? Twice of, because there are 2 quadrants, twice of pi x square by 4. Are you getting me? But we have subtracted this area twice, so we will add that, plus k pi x square by 2 divided by x square, divided by square area. This is given as P. I think the idea is clear now, because x square will get cancelled. We're left with only constants and k. So P will be 1 minus pi by 2 plus k pi by 2. Is it okay, Preeti? Okay, let us move. That was question number 25. Similarly, we have one more question. Find m in terms of k. Similarly, we'll make use of third direction where m is mentioned. In the similar manner, we'll calculate m in terms of k. Should I solve this sum or should I move further? Should I go further, guys? Please write explain if you have problem in this part as well. Okay, let us move. Question number 27 and 28. We had similar question in CAT as well, but with a change. The CAT question was based on number of factors only. Here we'll make use of sum of factors. Any problem in this question, 27 and 28? 27 was easier because in that case we could make use of options. Okay, let us see. Okay, Barry, I'll explain both these questions, 27 and 28. 27th question. Which bucket will finally have the maximum number of flowers? Now, there were 100 students and 100 buckets. So that is bucket 1, bucket 2, bucket 3, bucket 4. First of all, let us understand the meaning of this. Let us say there are 8 buckets. First student came. He put one flower to every bucket. Second student came. He put one flower. Let us see, it says the second student put two flowers in every second bucket. Third came, he put three flowers in every third bucket. Fourth came, 4 and 8. So basically, what is the idea here? We take any bucket numbers, let us say 8. So, how many students will put flowers in bucket 8? Obviously, they will be 8's factor. We can talk about 1, 2, 4 and 8 as 8's factor. So, these many flowers are put in bucket number 8. So it will be 1 plus 2 plus 4 plus 8. Let us say 5. If we say fifth bucket, only first student and fifth student. First student will put 1 flower, fifth student will put 5 flowers. So basically in this there will be 1 plus 5 flowers. So what is the idea? You take any bucket number, the number of flowers in that bucket will be sum of factors of that bucket number. You got that? So if we talk about question number 27, which bucket will finally have the maximum number of flowers? So let us say 96. Luckily that was the option, but we have to check it for every option, then only you can make what is the maximum number. You have to compare all the options. So if we take 96, now what is 96? That is 32 into 3, that is 2 raised to power 5 into 3 raised to power 1. So what is the sum of factors of 96? Sum of factors of 96 will be, we'll apply that formula, you must know that formula. That is 2 raised to power 6 minus 1 upon 2 minus 1 into 3 square minus 1, 3 minus 1. So what is the formula we are using here? If you want to find the sum of factors for any number, you write down the prime factorization of that number. Then what will be the sum of factors? It will be p raised to power a plus 1 minus 1 upon p minus 1 into q raised to power b plus 1 minus 1 upon q minus 1 into r raised to power c plus 1 minus 1 upon r minus 1, and so on. In earlier previous bull marks, I think we have discussed the whole factor theory. That is the sums formula. So by using this formula, you will calculate sum of factors for each and every option, and you will mark the maximum answer. Is it okay? Now coming to 28, how many bucket will finally have the exactly twice the number of flowers as the number on the bucket itself? So if we have, say, bucket number n, so what is the question asked? It says sum of factors of n that will be equal to twice the n. You got that, Berry Bounce? That was your problem. Sum of factors of n, sum of all the factors of n, that should be equal to twice of n. So what is the meaning of this question? Do we have any particular kind of numbers which satisfy this property? Yes, they are known as perfect numbers. How many perfect numbers we know? They are 6, 28. Are you getting me? Then the number is, I think, 396. That I think 8128, and so on. Now if we take 6, bucket number 6 I mean. Bucket number 6 will have 1 plus 2 plus 3 plus 6 flowers, which comes out to be 12, which is twice of 6. Bucket number 28 again will have 56 flowers. So we'll consider these two numbers only, because we have a range up to 100 only. Is it okay, guys? Okay, let us move. Question number 30th. Again, a counting problem. We'll count only. This is 7 raised to power 9. Yes, all of you? Should I skip this question? That is a counting case problem only. Okay, let us move. I think this again was an easy question. You got that? Say Ali, it says Madhu, Shilpa and Meher along with 7 other girls had reached the final of Miss Timbuktu 2003. Initially, all the girls had an average weight of 47.9 kgs. So in total there are 10 girls. Out of them, there are 3 girls whose names are given Madhu, Shilpa and Meher, and remaining 7 girls. Their average weight is 47.9. After the elimination of Madhu, the average weight got reduced to 46 kgs. If the average weight of rest of the girls is 3 kgs, then the average weight of Madhu, Shilpa and Meher together then is what? So what can we do here? Say their weights are x, y and z. So what is the thing given? X plus y plus z, and the remaining 7 girls. The total weight is 47.9 into 10, which comes out to be 479. You got that? Say Ali. Now, after the elimination of Madhu, so it will become y plus z plus the remaining girls. It will be 46 into 9. By solving this, you will get the average weight for Madhu. Clear? So, if the average weight of the rest of the girls is 3 kgs less than the average weight of Madhu, Shilpa and Meher together, what is the average weight of Madhu, Shilpa and Meher together? It is x plus y plus z by 3. And this is given that their average weight of the rest of the girls is 3 kgs less than. So, the remaining girl average, say that is A by 7, that is this thing given. By using this, you can find A in terms of x, y, z, and you can put the value here. Is it okay? We want to calculate Madhu's weight, but I think nothing is needed here. By using first two directions only, you can solve it for Madhu by taking the subtraction. Yes, exactly. Remaining is, the last line is redundant because we need to know the Madhu's weight. So it will be 479 minus 46 into 9 only, because we need to know x. Yes, Ali, if you are good at logic, we can do that. See, whenever you have a sum on average, you convert this into monetary terms. So we are considering that there are 10 girls. They have 47.9 rupees in their pockets. Is it okay, Sayali? One girl is moving out. If one girl is moving out with the same money, 47.9 only, then her money will be, then the remaining average will be 47.9 only. Are you getting me? Once again, let us see. You could go by logic as well. No need of equation in this. Once again, see, you will consider that there are 10 girls sitting in a room and every girl has 47.9 rupees in her pocket. One girl, Madhu, is moving out. Suppose she is moving out with 47.9 rupees only, then the remaining average of remaining girls will be same always, but average comes out to be 46 rupees. Average falls by 1.9 rupees. It means Madhu is taking 47.9, that was her share, plus 1.9 into 9, that was the extra share of remaining 9 girls. So Madhu is taking this thing. Is it okay, Sayali? Okay, that was a simple question on average. Okay, question number 34. Again a medium level question, but huge data. See the pattern of TSD questions. Whenever you see TSD questions, either you get a caselet, 2 or 3 questions based on a story, or a huge data. Any problem in this? 34th. M and N are 2 stations on a railway line. A single rail track is present between these stations. X, Y, Z are 3 trains that run between M and N. X runs half as fast as Y. So there are 3 trains, X, Y and Z. We will find the ratio of their speed. Let X speed is 1. Now X runs half as fast as Y. So Y speed will be 2. I'm writing speeds ratio, which in turn run at a speed of 33, 1 by 3% less than that of Z. So Z speed will be 3. Is it okay? That is a simple percentage thing. So their speed will be in the ratio of 1:2:3. Because there are 2 stations, M and N, and there is a single railway track. So at one time, only 1 train can move. Each day, X leaves M at 7 a.m. for N, and as soon as it reaches N, Z start from N and reach M at 9 a.m. So basically in 2 hours, in the span of 2 hours, X is going from M to N and Z is coming from N to M. Are you getting me? They have 2 hours to complete this process. Are you getting me, guys? I think you are okay with the ratio part. Yes. Okay. So we'll take the data for x and z. Say x and z, their speeds are in ratio 1:3. Y is not needed in this case. We'll make use of y to find the ratio only. So x and z, the speeds are in 1:3. Now in the given data, in the given rotation, the x and z, they both are covering the same distance. As we know, whenever distance is same, ratio speed and time, they are inversely proportional. So speeds are 1:3. So time will be 3:1. They have 2 hours between themselves. If they have 2 hours, that is 120 minutes. 120 minutes. If we divide 120 minutes in 3:1 ratio, it means x will take 90 minutes and z will take 30 minutes. Is it okay, guys? You got that? I'm making use of ratio. No equation is needed here. So usually, what is the story? X start at 7 a.m. This train takes 90 minutes to reach N, and after reaching at N, Z start from N to M towards M, and it reach at 9 a.m. and taking 30 minutes to reach M. That is the whole story we have concluded by using the statement. Now, one day X started 24 minutes behind the schedule. If 24 minutes behind the schedule and we need everything on time, so out of 120 minutes, already 24 minutes are wasted. That's why we are left with only 96 minutes. But increase its speeds by 11.9% to try to catch up on the schedule. It means initially it was taking 90 minutes. Now it has increased its speed. Now what is 11.9%? That is a fraction 1 by 9 only. So its speed become 11. That will be 10 by 9. So its time will become 9 by 10. So its new time will be 9 by 10, which is 81 minutes. Is it okay? Clear? X speed is now 10 by 9. Yes, once again, Sayali. So it says that X has increased its speeds by 1 by 9%. What is the fraction for 1 by 9%? That is 1 by 9. So if we consider that X speed was originally 1, so its new speed will be 10 by 9. 1 plus 1 by 9, which comes out to be 10 by 9. If its speed is 10 by 9, the new time will be 9 by 10. Because time and speed, they are inversely proportional. So its new time will be, original time was 90 and the new time will be 90 into 9 by 10, which comes out to be 81 minutes. Is it okay, Rashmita and Sayali? Is it okay? Please confirm. Okay. So X has taken 81 minutes. We had total 96 minutes. It means Z has to take 15 minutes to cover the whole thing. Now Z was taking 30 minutes and Z has to take 15 minutes to cover the whole distance. It means Z has doubled its speed. Is it okay? Can we say this? Z has doubled its. So what was Z's original speed? That was 3. So Z has doubled its speed. So what is the new speed? It will be 6. Now you can find the ratio. Yes, exactly. 11 1 by 9% Sayali. This is percentage. You know how to convert percentage into fraction. You will divide it by 100. I think at this stage when cat is very near, you must know percentage conversion. For example, 50% is half, 25% is 1 by 4. We can say that this is 11.11%, which is 1 by 9. Okay, so let us move. Question number 36. Now it was AR. AR was moderate level. Only 1 or 2 sets was very difficult. Otherwise that was an okay set. Yeah, any problem in this? Let us move further. Let us see. It says 4 colors, white, blue, green and orange, are used to paint a cube such that each face is painted in exactly one color and each color is painted on at least one face. The cube is now perfectly and completely cut into exactly 120 identical cuboids. by making the least possible number of cuts. That was an important line. Say, suppose I'm taking a smaller example. So we have 4 by 4 by 4 cube, and we want to make cuts on every face such that we have cubes of 1 by 1 by 1 dimension. So how many cuts are needed? Can you say 3 plus 3 plus 3? Can you say this? These many cuts are needed. You have to visualize this. Please confirm. Okay, so let us see. We have 120 identical cuboids. So the volume is 120. So dimension, suppose we have taken A, B, C. So how many cuts? Suppose 120 is equal to A into B into C. How many cuts are needed? A minus 1, B minus 1, C minus 1 in the similar manner. We want to minimize this thing. If we want to minimize this thing, we will try A and B and C. They are almost equal. Okay, Ashish, let us see what I'm trying to tell you. We have a cube, suppose of dimension 4 by or 3 by 3. How many cuts you will make to do so? Suppose I'm considering this face. If the dimension is 3 by 3, you will make 2 cuts. Again, you will make 2 cuts here. Then you will make 2 cuts here. So how many cuts are needed? Can you say 3 by 3 by 3 cube? We have 2 plus 2 plus 2 cuts. So whatever be the dimension, we'll take minus 1. You got that, Ashish? Okay. Same is the thing I'm using here. What was the dimension given? Volume given, it was 120. Let the dimensions are A, B, C. So in A into B into C, that should be equal to 120. So how many cuts are needed? A minus 1 plus B minus 1 plus C minus 1. I'm subtracting 1 from A, B and C. So these many cuts are needed. Question says the number of cuts should be minimum. If it should be minimum, A plus B plus C minus 3 should be minimum. Then A plus B plus C should be minimum. So A plus B plus C can be minimum if A, B and C are closest. So this 120 can be written as A into B into C, where A and B and C are closest. The only possibility is 4 into 5 into 6. So how many cuts are needed first of all? Cuts are needed 3 plus 4 plus 5. These many cuts are needed to make this kind of cuboid. Is it okay? Clear? Now what is the question? What is the maximum possible number of cuboids which have more than one face painted in the same color? What is the maximum possible number of cuboids which have more than one face painted in the same color? So what will we do? This is the cuboid of dimension 4 is to 5 is to 6. Now according to the question, any face, its dimension can be either 4 into 5 or 5 into 6 or 4 into 6. Now what is my question? It was find the maximum possible number of cuboids. We want to maximize this thing which have more than one face painted on the same color. More than one. So if we want to maximize the number of cuboids which have at least 2 faces painted with the same color, so our try will be, see there were 4 colors, say they are blue, red, orange and yellow. So our try will be, we'll take one color on each face and one color is used thrice on 3 faces. Is it okay? Say let us blue. Blue we are using 3 times. Red is used once, orange is used once and yellow is used once. Is it okay? And what will be the location of those faces? It will be, suppose we can take this face. Suppose this is blue. This is blue. I mean to say that all 3 are adjacent. If we consider these 3 faces to be blue, we will maximize. See, you can see these 3 edges are common here. On these edges only we'll get our required cubes. Are you getting me? More than one face is painted with same color. So it will be this corner cube. Its dimension, say this is 6. This is 4. This is 5. First of all, from this edge, we'll get 3 plus 4 plus 5 plus this corner cube. So these many cubes are the required answer. 3 plus 4 plus 5 plus 1. This is a case of visualization only. I've tried to make a diagram. Is it okay, guys? So this will be the answer in this case, 13. Now the next question, 53rd. Any problem in this? Since we are short of time, please make it fast. For every question, we have to consider different cases. I think the idea is clear now, because the main problem was the dimension. It is 4:5:6. Now that was a difficult set. Any problem in this? 54th. Yes. See, what is the question? You have read the statement. There are 3 persons. The turns are Ram, Sham, Mohan. Coming to question directly. For which of the following basic number will Ram win? The turns are, first of all, Ram, then Sham, then Mohan, then Ram, then Sham, then Mohan, and so on. And question is, for which of the basic number will Ram win? Options are 12, 23, 34. I'll explain the whole set because I think that was a difficult set. I'll consider, suppose there are, how many sticks are here? Nothing is mentioned, so we will take, of course there should be 3 sticks because there are 3 persons. Suppose there are 3 sticks. Everybody is playing intelligently, so everybody tries to win. If it is not possible for someone to win, he'll try that the next person to him loses. Because if you are next to winner, you will get 1 point. Winner will get 2 points. So let us start with Ram. Ram can take either 1 stick or 2 sticks, that is mentioned in the question. Whatever he takes, Sham will always win. So 0 point will be given to Ram, 2 point will be given to Sham, and 1 point will be given to Mohan, because Mohan is next to winner. You got that? First of all, whatever Ram takes, either he can take 1 stick, so he'll be left with 2 sticks that Sham will take, so Sham will be winner. Suppose Ram is taking 2 sticks, so he'll be left with only 1 stick, so Sham will take that stick, Sham will be winner. So whatever be the case, Sham will always be the winner. So Sham will get 2 points. Since Mohan is next to winner, he'll get 1 point. So Ram will be the loser, he'll get 0 points for this case. You got that? Preeti, Adhiraj, Tanya, Soumya, Mohit, Ashish. Is it okay? Let us take, there are 4 sticks. If there are 4 sticks, in that case, Mohan will be the winner always. See, if Ram, we have to consider cases only. Suppose Ram is taking 1 stick. So how many sticks are left? 3 sticks. So how many sticks Sham can take? Either 1 or 2. Mohan will take either 2 or 1 respectively. So Mohan will be winner always. Of course, Ram cannot win in this case. So Ram will try that Sham loses. So he can be next to the Mohan, next to the winner. So Ram will try that Mohan wins. Suppose Ram is taking 2 sticks. Then in that case, Sham will be the winner. But in that case, Mohan will be next to the winner. In that case, Ram will get 0 points. Since Ram is playing intelligently, Ram will never take 2 sticks. Because in that case, he'll get 0 points. Are you getting me or not? Everybody tries to win. If he cannot win, he will try to be next to the winner so that he can get 1 point. So this is the possible case. So in this case, Mohan will always win. Mohan will get 2 points. Sham will lose and Ram will always get 1 point. Are you getting me? It was a good set. Similarly, if we take 5 sticks, Ram will be the winner always. Sham will be the second and Mohan will lose. Is it okay, guys? Are you getting me? Please confirm. Okay, similarly, if we take 6 number of sticks, Ram will always win. Sham will get 1 point and Mohan will get 0 points. We can consider all the cases. So Now coming to question number 54, which says for which of the following basic numbers Ram will win. Now as you can see, this is 4k plus 3 type format. This is 4k, this is 4k plus 1, this is 4k plus 2. So if the number of sticks are of this format, 4k plus 1 or 4k plus 2, Ram will always win. So going by option, if we have 12, this cannot be the answer, because in that case Mohan will win. If we take 23, then in that case Sham will win. And if we take 34, 34 is 4k plus 2 times. So in that case Ram will always win. That's why third option, that is the answer. We'll exploit the same logic in the remaining sums. You got the idea, all of you? Okay, that was the last question, 59. Any problem in this? I think that was very easy. Yes guys, any problem? If you want me to explain this question, please write it. Easy, actually easy. Yes. Okay, that's it for today guys. See you next time, and best of luck for the next paper. Thank you so much.